So we're looking at E11, and we're going to write our given, and we're going to write our find. We're going to chunk, which means we're going to read, we're going to write. So it says a block weighing 98 newtons. So that's not the mass, that's the weight. F of G is 98 newtons. Falls 64 meters, so that's our height. What is the potential energy of the block at 64 meters? So we want to find the potential energy. What is the speed of the block when it strikes the ground? So we want to find Vf. So if we look at this, here's my block, and it's going to fall. And here's my ground, which we always refer to as base level, and it's going to fall 64 meters. And they give us the weight. So for part A, to find the potential energy, we know that potential energy is equal to mgh. And we know that mg is equal to the weight. So I can say F of G times h. So it's going to be 98 newtons times 64 meters. And the potential energy at the top is going to be 6272 joules. And then again, in correct significant digits, we'll do 3, because this has 3 and this has 3. So our final answer has to have 3. Okay, so that's the kinetic energy, the potential energy at the top. Now remember, the kinetic energy at the top, if we wrote out conservation of energy, we know the potential energy at the top is going to be equal to the kinetic energy at the bottom. But just in case we didn't remember that, in layman's terms, we know the total energy before is equal to the total energy after. So we have KEI plus PEI is equal to KEF plus PEF. Now initially it's at rest, so this goes to 0. And the potential energy at the top is mghi, which we already found. And then at the bottom, the height is 0. So this goes to 0. So this is going to be equal to the kinetic energy at the bottom. So if I want to find the speed, I already know this. So that's equal to KEF. And I know KEF is equal to 1/2 mv squared. So if I rearrange this equation to solve for the unknown in terms of the known, I have 2 KEF is equal to mv squared. I multiply by 2. Then I divide by m. 2 KEF over m is equal to v squared. And then I take the square root of both sides. So the square root of 2 KEF over m is equal to v. I don't know v, so I'm going to go back over here and I'm going to just say F of G is equal to mg. So F of G over G is equal to m. So I'm going to say 98 newtons divided by 9.8 meters per second squared. And I don't really need a calculator because 98 divided by 9.8 I can see is 10. So the mass is equal to 10 kilograms. So once I see that the mass is 10 kilograms, I can substitute it in here. And now I'm going to say square root of 2K. Oh, I already wrote the equation. So the kinetic energy was 6270 divided by 10. And when I put all that in my calculator, VF comes out to be 34.5 meters per second. Once we do a lot of these problems, we kind of get the whole swing of the total energy before is equal to the total energy after, which is the sum of the potential and the kinetic energy. And that's it.